Welcome, good morning, and good afternoon, Eaton Nation. I'm Adam Bainbridge, your guest host for today's Ask the Expert event. Today, we are taking your questions about the differences between NEMA, IEC, and DP contactors. But first, let's meet our presenters for today. First, say hello to Product Manager for NEMA contactors, Ms. Asma Matlani.
Hi, I'm Asma Matlani. This is my first Ask the Expert, so thanks for having me.
Welcome. And you know him as the host of All Things Control by Eaton and your friendly neighborhood contestant on Oh My PLC. Please welcome Product Manager for our IEC contactors, Mr. Josh Kingsley.
What up, everybody? Glad to be here for this session and glad to be on the other side of the table for this one.
Great. Welcome to the team. Let's get some housekeeping out of the way. To our audience, you can ask your questions via the comment sections below on LinkedIn or Facebook. And, as an added bonus, you can download a free quick guide that walks you through their criteria for selecting a contactor, called the Contactor Selection Quick Guide. We will show you how to do that at the conclusion of this presentation, so stick with us through the end. And this Ask the Expert session is brought to you by Eaton's comprehensive line of contactors and starters, featuring Eaton's industry-leading Freedom NEMA contactors, the feature-rich XT IEC contactors, and reliable and competitive definite purpose contactors. Visit eaton.com/contactors to explore the entire portfolio. Now, let's get to the questions. I'm seeing our first question come in on LinkedIn. Looks like this question's from Harold, and Harold says, I know I need a standard contactor, but I'm not sure how to select one. What is the best starting point? I'm going to begin with Asma on this one.
Sure thing, Adam. And, thank you, Harold, for asking this question. Comes up very often, so it's definitely a great way to start the session. Selecting a standard contactor is going to always start with your application consideration. It's a good rule of thumb. So when you're doing this, there's a few key things that you need to ask yourself and kind of make sure that you've figured out. The first being the type of contactor you're going to need. So this could be the NEMA, the IEC, the DP, and then taking it a step further into full voltage non-reversing, full voltage reversing, etc. Second, you're going to want to know the type of control or coil voltage that's going to be used in this application. Third, the application, is it three-phase, single-phase, DC, what have you there. Fourth, the type of overload protection that you'll need, whether it's no protection, bimetallic, solid state, or advanced motor overload. Fifth, you're going to need to know accessories. So this would include heater packs, auxiliary contacts, mechanical interlocks, fuse blocks, etc. Sixth, this would be load. So full load amps, motor horsepower, what are you looking for from that standpoint? And finally, I would say enclosure. So whether your product's going to be open or enclosed, do you plan on having it as an enclosed unit? If so, you could have it in a NEMA 1, 3R, 4, 4X, or even a 12 enclosure.
Wow, that's great information, Asma. I didn't know so much went into the selection of a contactor. And thank you, Harold. I hope that answers your question. Okay, let's see. We have another one coming in from LinkedIn. This time it's from Samuel, and it's a good one. What is the difference between NEMA, IEC, and DP contactors? Hey, Josh, can you take this one?
Yep, sure thing. And hey, Samuel, thank you for the question. So we'll start with NEMA contactors. NEMA contactors are a North American standard device. So think if you're measuring something, you're using inches as a good example to drive that there. So they're known for extreme durability, and they're going to have a high price point to match. And then they're also going to have some international uses when you're thinking of extreme environments. I mean, mining, I think, is the place where we'll see the NEMA contactors overseas. But for the most part, these are going to be a North American specific device. The IEC contactors are going to be the truly international devices, so think measuring in centimeters and millimeters, and they're going to have the rating structure that'll cover the international rating needs. They're also going to cover pretty much the same applications as a NEMA contactor, but they will have a lower electro and mechanical lifespan, and so typically they're going to have a lower price point as well. Want to make sure being clear, these are my products and they're also quality, but they're not going to be near the girth of the NEMA contactors that Asma runs. So the DP contactors are the third one. These are going to be really price point driven and were essentially made for the HVAC market, which is highly competitive and very price driven. So they're going to have some pretty specific application ratings and lower operation capability, but they are priced accordingly.
All right. And by priced accordingly, do you mean that DP generally have the lowest price of the three?
Yeah, for sure. That's right. And Ozma, feel free to jump in if I'm not speaking well enough of your stuff.
No, I think you're doing great.
Back at you.
Nina's awesome.
All right. Let's look for another question. Okay, this one's from Tom. The question is, can I change a DC coil to another DC voltage coil in a Freedom contactor or starter? Ozma, I'm going to throw this one at you.
Yeah, so that's a great question. So let me think on that one for a sec. So the easiest way to probably do something like that would be if the Freedom series already has a DC coil in it, it can be swapped with another DC voltage coil. It's only necessary to change the coil as the complete conversion kit is only needed to swap it from AC to DC. So kind of to summarize my thought there is if you have a Freedom contactor that currently is an AC, so 120 volt AC, and you wanted to swap it to a DC, we do have complete conversion kits. However, if you already are using a DC coil in your contactor, you don't have to get the conversion kit in order to switch.
Okay. Thank you, Ozma.
Mm-hmm.
All right, here. Oh, this one looks like a challenging one. This one is from Ben on Facebook, and Ben asks, what is the difference between AC1 and AC3 IEC contactor ratings? Josh, I think this one belongs to you.
Yeah, for sure. Thank you, Adam, and thanks, Ben, for the question. So this is actually what I'll call a really high-level cut of what the application is. So think back to Ozma's first answer that she gave, talking about the application. So this is a really high-level application. AC1 is going to be a non-inductive load, and I think it's written in the standards as a resistive furnace or a heating load as an example within it. And then AC3 is going to be an inductive load like a motor, and I believe it's specifically worded squirrel cage motor. So just think about what the motor is actually going to be doing and if it's going to be, or what the actual application is, and whether it's a motor that's going to be running in a circular fashion, or if it's going to be something more like a heating load. So Ozma, add anything in, because I know it's roughly going to be the same thing when you're talking about NEMA applications, but those are probably the two most common AC applications.
Okay, that sounds great. So, I mean, that honestly sounds pretty complicated, but from your explanation, it really sounds pretty straightforward, huh, Josh?
Yeah, I'd say it's pretty straightforward. Like I said, it's the two most common applications. If you look at most of the IEC contactors, you're going to see that actual full load amp rating for both of those two application categories listed on the sticker. AC1, AC3 are the most common AC applications.
Cool.
Can
Okay.
I add something to that by chance? With the utilization categories being like more standard across the board, if you are utilizing something and you don't know which utilization category you're going to fall into, the IC standards list out the utilization categories pretty detailed. So if there is one of those situations, you can likely just kind of Google it, honestly, or go to any search engine and just type in what utilization category you're looking for and if you fit into it.
Okay.
Yeah, and I would also imagine you can probably just grab the catalog for whatever contactor family you're looking for, and they're going to list those as well.
Perfect. All right. Hope that answers your question, Ben. Okay. Looking through the questions again. Let's see. I see Eric V on LinkedIn. He says, "Hi, colleagues. Great to be on the call. Hey, it's great to have you here. I really appreciate you taking the time to listen in our session here. And just as a reminder, please submit questions. We have the experts here. We're looking forward to you guys challenging us a bit. So anything about contactors, NEMA IC or DP, now's your opportunity. So go ahead and post those questions below. Okay, let's see what else we got for questions. Let's look here. Sorry. Okay, this is an interesting one. What are the mounting options for Freedom contactors and starters? Ozma, I'm going to throw this one at you again.
That's a good question. So the Freedom line of contactors and starters, they can be mounted, they can be mounted vertically or horizontally depending on the size of the unit. In our catalog selection guide, so if you're in like volume 5 on like page 3, in the footnotes, we kind of explain what the size restrictions are. I believe it's size 3 is where we cut off where you can't be horizontal or where you can't be either or. But those are, you can either do horizontal or vertical, and then the springs and coils are designed to provide proper operation for the required mounting positions. So for those sizes, the double aught to 3, I believe, that can accommodate that. It's due to the springs and everything internally, allowing it to function the same in either orientation.
Okay, so a lot of flexibility. Yeah. It sounds like that's great. Okay. Oh, here's a follow-up to one of the previous questions from Ashwin on LinkedIn. What can be an estimate of contact life on AC1 and AC3 contactors if nearly 80% of the load is used? Josh,
so the best way to answer that question is to look at the life curves based on how much of the current load that you're using. It's going to look fairly similar across the frame sizes, but I don't know that there's a specific number that I would throw out.
Oh, okay. Towards the end of the event, when Adam shares the QR code for the downloadable document, when Josh and I were putting together the content for that document, we did include a life curve and kind of like an example on like how to select where you are in that life curve just to get an estimate. So that'll probably be helpful when you're doing that in the future.
Yeah, perfect. It's pretty easy to understand. It's a linear graph, and you'll see the curve based on number of operations and based on the current that you're using. And there's obviously other factors that can play in when we're talking about environment, heat, things of that nature. But the curves are going to be the best place to start, and then look for any kind of derating that you need to account for as well.
Great. So that's in the application note we're going to share at the end, and also in the catalogs, I think I heard, and the product documentation.
Yeah, the detailed data sheet should have every single one of those, especially in the IEC side. And I think, Ozma, your stuff is going to look pretty similar. It'll be in the resources tab.
Yeah.
Okay, perfect. All right. Looking for questions. We're a little light. If you guys have anything, please submit them. Again, looking forward to answer your questions for today. So if you have any questions, please post them up.
I mean, don't make us resort to Adam telling jokes. That's probably the direction we're going to have to go with.
I don't know any good ones. Okay, let me look here.
I mean, we could always just turn this into a Oh My PLC part 2.
We could.
Yeah.
We could.
Here's a good one. This is from Kavita, and she's on LinkedIn. She asks, when do I use KW or HP to select a contactor? Ozma, can you take this one?
Oh, definitely. Thanks for the question, Kavita. KW is the kilowatts and HP is the horsepower. So both are measures to rate your motor by. In NEMA or the North American standards, we typically will look at our motor in horsepower ratings, whereas in IEC type applications, you're typically going to see more of the kilowatt rating standpoint. Those are, and if you're unsure where to look on your motor label for that information as well, it's also in that application guide, just like circled, like explaining like where you'll see that information generally. But that's kind of the general rule of thumb between the kilowatt and the horsepower for selection criteria.
The extra point that I'll throw out, if you look at an IEC contactor, you're going to see both ratings typically on the label and then in any data sheets or in the catalog. I would go a little further than what Ozma said. In the US, we use horsepower, and in the rest of the world, they're going to look at kilowatt ratings, and you're roughly asking for the same piece of information. It's just represented differently. and it's just calculated differently. There's not a clean way to convert between the two, but like a data sheet for any XT contactor, you're going to see a horsepower and a kilowatt rating. So it's really pick your poison, decide how you want to set the application, and a lot of times the motor plate will make that decision for you.
Well, and not only that, but even if you have, I've seen this come up a few times where a customer has their motor rating in kilowatt, however, they still want to use a NEMA contactor for whatever reason, perhaps likely because they already are using the same contactor elsewhere in their plant and just want consistency. You can reach out to like our technical resource center or any of our application engineers, and they can kind of help you figure out which NEMA product would work with that kilowatt rating, or vice versa for the IEC products.
Yeah, echoing that plug for our TRC. The TRC is a great resource and usually the most responsive people to help you set your application. So a big shout out to those guys. And gals, they do a great job for us.
Excellent. So this is a standard versus metric thing, and nobody in the rest of the world really understands how much is in a horsepower, huh?
Yeah, I mean, I think they do when they need to, but they're not going out of their way to figure it out.
All right. All right, we got a few more questions. I appreciate it. Keep them coming. Katie on LinkedIn, do you see a transition to IEC in the U.S. market? Josh, I'm going to let you answer this one.
Yeah, I would say as a whole, that's kind of a trend that's coming. And I mean, it's not that we're necessarily seeing it happen overnight where people are changing in the middle of the night. I mean, Ozma can attest to that. We still do our fair share with the NEMA contactors, but I mean, the big thing that I'll point out from the first question that I answered is it's a price point situation that can come into play in addition to the girth needed for the actual device itself. And then the other thing to think about is if you're trying to ship product potentially overseas. So if you don't necessarily have to have something built like a tank and you want to save some money, IEC contactors are a great way to do that. And so in some ways, the decision's made for you. If there's a possibility that you're going to be shipping overseas, you might be having to get into IEC regardless, unless you're talking about one of those applications like mining or any other places where you might see a NEMA contactor just because you need the really robust device. But I would say it's a trend, but we're going to be kind of working through it for a little while.
Okay, sounds great. Arthur on LinkedIn has a good question that I think carries over from the last one pretty well. Are there any major size differences between NEMA, IEC, and DP? I know, Josh mentioned, NEMA is built like a tank, so, I mean, maybe it's a lot bigger, but Ozma, let us know. I mean, is there any major size differences?
Yeah, I mean, we do have some sizing differences when you get to the larger sizes, but in the smaller frame sizes, they're relatively comparable. Even in the Freedom catalog for Eaton's products example, we kind of list out what IEC frame size products, because we do also have like the Freedom IEC related products. So we kind of show like where the crossover is on those sizes. So like I mentioned, like in those smaller sizes, I'd say maybe 4 and below, they're relatively comparable with just minor differences maybe on the depth. I think the depth is probably the most important one that we see differences on. But then once you go to those big sizes that are relatively more infrequent, that's when you get those big differences. And Josh, please correct me if I'm wrong on that one from the IEC standpoint.
No, I'd say that's pretty accurate. The frame width is going to roughly be the same. So you'll have a frame one contactor is going to be 45 millimeters wide, and however that converts into inches, I'm not trying to do that math in my head right now, but that's generally going to be pretty universal. And from my experience, the width is probably the most critical of all the dimensions, and then depth would be the second one. And as Osman mentioned, there's going to be some differences right there. But when you start throwing things like front mounted aux blocks on there, that can change the game a little bit as well. And then the heights are probably going to be relatively the same. And the NEMAs might even be shorter a little bit in some instances. They seem to be a little like bulkier on the depth and a little shorter. So they're more built like a tank, if you will. And if you're getting into a fight and a contactor's your weapon, the NEMA is the one that you want to go with. But then I don't think the weight normally comes to be a consideration that you're really looking at very often. But the NEMAs are probably heavier, right, Ozma?
Yeah, it's comes down to the materials. They just get very bulky very quick. And to your example, the 45 millimeter, we like list out in the Freedom catalog by millimeter size as well for our frames. So for example, like the size double aught is also a 45 millimeter. So from that standpoint, they are comparable. But yeah, they're definitely heavier.
Yeah, I mean, if you're looking at an application and you're trying to fit into a panel, I mean, generally speaking, in the OEM world, you're trying to fit as much as you possibly can in there. So the course of 5 millimeters, which is roughly a quarter of an inch, that's going to make a huge difference in terms of spacing and what you're going to have to do from a panel standpoint, because you don't want to be buying any more steel than you have to, or whatever you're making your enclosure out of. And anything that you can do to keep that as compact as possible is going to make it, one, better for the panel builder, but two, better for the real life application. You have less space that you have to make up for when you're trying to put everything together.
Okay, great information. And I want to give a shout out here. So you guys might have seen him in the comment section. There's this guy named John that seems to have a lot of knowledge. Well, John Ross is an application engineer here at Eaton, one of many. Very, very knowledgeable individual. So I just want to give a shout out to John Ross. John Ross. I apologize. Is a application engineer for our central region, and he's in the comment section helping answer your questions as well, the ones that we're not able to ask on the air. But we have in our technical resource center, we have people waiting to take questions every day about contactors and all of our Eaton products, and then we have these field application engineer resources who can help come in and help you understand things about your application, different SCCR ratings, whatever, a lot of complicated issues. They can help you navigate those issues and get the right product and the right specifications in your system. So again, I want to thank John for helping out today. Okay.
Yeah, definitely echo that. Definitely echo that. If you have the pleasure to talk with him, you'll certainly learn something.
Also, if I can add, the TRC did make like this really helpful tool that's on our website. If you're on any of the product pages, on the left-hand side, there's like a little question bubble for frequently asked questions, and you can kind of type in generally what you're looking for. And there's like a lot of common FAQs that pop up there as well that they've populated over the years.
Okay, excellent.
Yeah, definitely use that chat widget. It's great. A lot of good research and effort was put into making that be something that helps make things user friendly. It's always nice to be able to get on the phone and talk to somebody, but it's also nice sometimes to just be able to get an answer and move on with your life.
Yep. All right, we have another good question from Jorge on LinkedIn. You've mentioned the IEC are typically used outside the USA and NEMA more for the US market. What is the market for DPs? Ozma, do you want to take this one?
Yeah, so that's what's great about the definite purpose contactors is they're like a wonderful floater type product. They're really applicable across the board. We do have like globally applicable IEC and NEMA based DP contactors that meet all of the global requirements. So they're used in both Europe and Asia, et cetera, in the US as well. And then we also have DP contactors that are specific to the US. And, all of those, they can be used across a lot of lower applications. So like I wouldn't, of course, recommend them for anything like mining or chemical or oil and gas. But if you're an OEM and you have a standard panel and you expect cycles to be relatively simple and under 100,000, you could use them globally and it would be pretty great.
Okay, thank you. Another good question on LinkedIn from Eric. Is it better to use AC or DC coils? Is there any reason to use one over the other? Josh, I'm going to ask you to answer this one.
Yeah, so there is a trend of moving towards DC to get into lower voltage and to potentially avoid PPE. So if you can spec an application to 24 volt DC as opposed to having to use the 120 or 240 AC, you can potentially avoid having to put on the arc flash suit and the helmet. Your maintenance people are probably going to get really upset that they don't have to go into a 100-degree, enclosed motor control center type of building and also have to wear heavy leather and a helmet, but they'll probably get over it and be okay with it. But that's probably another trend that I would point out is just moving to DC to try to avoid things of that nature.
All right. Good answer. Thank you. Hope that answers your question, Eric. One more on LinkedIn from Eloy. I hope I'm saying that right. Eloy asks, what's the max auxiliary contacts you can provide on the NEMA and the IEC contactors? I'll probably pose this to both of you.
I believe on the Freedom you can have up to 4, but I would have to double check, and I think I can check our catalog and get back to you just to verify. I don't want to give you the wrong information, but if memory serves correctly, you can have a maximum 4.
Yeah, so the max that we're going to have that's on board with a contactor in the smaller frames, it's going to be either a 1 normal open or normal close. So that's going to be the frame 1 and 2, or the B and the C, which are the 45 millimeter contactors. With aux contacts, you can add different configurations. Our safety contactors probably have the highest amount of aux contacts that are on the device. And so those are going to be 3 and 2, 3 normal open, 2 normal close. But we do have safety contactor relays that have like 4 and 0. So I would say that 5 is probably, what you're talking about.
Okay. Got a question from Travis. When should I purchase a motor starter versus a variable frequency drive? It's a good question. It's an interesting one. Josh, do you think you might have the answer to that?
Yeah, so I would say the short answer is the motor going to run at a constant speed and just turn it on and off, or is it going to be running at a variable speed? Because the variable frequency drive is made for being able to run at variable speeds, which will be controlled by the frequency. But if you just need to turn the motor on and off and the inrush is fine, then a standard starter is going to be great. If you need to not have the massive inrush up front, then you can use a soft starter to help ease in.
All right, great answer. Got another question, and I hope that answers your question, Travis. I definitely want to thank everybody who's given questions so far. I really appreciate a great conversation happening here. I have one more from Tariq on Facebook. What makes NEMA contactors more expensive than IEC contactors? Josh?
Yep. Good to meet you, Tariq. So the NEMA contactors are going to be larger, have longer lifespans, and be designed to have internally replaceable parts. So Ozma could probably talk a little bit more about this. You're not going to hear about replacing heater packs on an IEC contactor. A lot of times you can swap the coil if you need to change voltage or something to that effect. You can change out the external aux contacts, but for the most part, if you need to replace parts on an IEC contactor, that's just called buying a new contactor. Osman, you can expand on what other kind of things that you can replace on a NEMA contactor, but a lot of it, just think more material built like a tank, so it's going to be more expensive.
Right. Well, and not only that, but because it's more expensive, it's worth more to swap out some components if they're going bad, like your contacts or your aux or your armature and magnet. And like Josh mentioned, like you're not typically going to see that on the IECs or the DPs, just because from a cost standpoint, it doesn't make sense to swap out those components. With the NEMA contactor, it does, because it is slightly more it's a bit more costly on the product itself, but a lot of that does lend to the materials that are being used. And like Josh mentioned, I think earlier, and I think one of his first questions was, the lifespan that you're seeing, the electromechanical longevity that you're going to see with a NEMA contactor. You pay for the quality, and that's what you're going to get out of it. So it's a little bit more expensive upfront, but from a long-term standpoint, if you're going to be using this thing heavily for a long period of time, then it'll balance itself out.
Okay. Well, I think we're going to take one more question. And I also want to encourage everybody, if you have more questions, to, submit it in the chat after the event closes, and we can continue to answer those. So, continue to post questions as you think of them. But the last question I'll pose to the team is from Salem on LinkedIn. In a group mounting configuration of panels, it's usually for IEC. Is that applicable for NEMA 2? Ozma, I'm gonna pose this one to you.
So I think I've gotten this question one time during this time, so the TRC may be a better point of contact, but I know it's possible. I unfortunately just can't dive into the details of it myself, but I can reach out to some of our engineering team members and get more technical backing on that and get back to you.
Okay, sounds great. Thank you. I'm gonna pause here, and at this time I'm gonna show that QR code we were telling you about. So all you have to do is open the camera on your phone, point the camera to the code, and it will take you to where you can download the application note. We'll leave the code up for a moment. So again, if you just open the camera app on your phone, you don't need to snap a picture, just hold it up so it can see this QR code. You should see a pop-up. Click that pop-up, and it will take you to your browser, and you should see that application note after that. So definitely a great resource. I encourage you to download it. And we'll also post the code on the event page at the end of this broadcast. And to learn more about our full portfolio of contactors, visit eaton.com/contactors. So definitely a great resource there as well. I want to thank Ozma and Josh for joining us. And thank all of our viewers for tuning in. Join us next month for another Ask the Expert Live, where we will be talking about harmonics. Thank you, everybody.